Welcome to today's lesson at 6.4, Compound Inequalities. Go ahead and put today's date. And what we hope to be able to do by the end of this lesson is that I can solve and graph compound inequalities. Period. There you go. So first thing we're going to look at is the word compound. Compound means we're going to be dealing with more than one inequalities. So we're going to have two types of compound inequalities. With two inequalities in each. Now to learn about our two types of compound inequalities, I made a quick little table for us. So if you'll make 3 columns, the first column is titled the type of compound. We said there was 2 types of them, so the type, then the definition, and an example of each. Alright, so our first type we're going to look at, if you want to give yourself about 3 lines, first type of compound we're going to look at is AND. And is the intersection. It wants in between or the middle of inequalities. So and is the intersection, and it wants everything in between or the middle of inequalities. Now for our example, and inequalities can be written 2 ways. The first way is if I have -2 is less than x, and x is less than 4. Well, there's 2 inequality symbols here. If you notice, they both point to the left. So that reads -2 is less than x. So if I break them apart, I can say -2 is less than x. And, because it's an and inequality, our variable's in the middle. It says it wants in the middle. So write the word and. Our second part is x is less than 4. Now, if you remember from the previous part of inequalities, we like to have our variable on the left because it makes it easier on us. So what we're going to do is flip this first one. So if you remember, whenever we flip something, I have to flip the inequality symbol too. So like I said, just remember whenever we flip it, we have to flip the whole thing. So I have to bring my x to the left, have to flip my inequality symbol, and I take my -2 to the right side. I'm just going to drop down, and x is less than 4. So both these inequalities say the same thing. We have -2 is less than x is less than 4. So if I look in the middle, it actually reads x is greater than -2, which I have right here. X is greater than -2. And, because x is in the middle, x is less than 4. Now, when we graph this on a number line, we'll have to watch our graphs and make sure we get everything in between. So I'll put -2, -1, 0, 1, 2, 3, 4. And if you notice, all my units are the same. I count by ones. -2, -1, 0, 1, 2, 3, 4. Alright. So at -2, it wants an open circle and says x is greater. We know greater is to the right, and also the inequality symbol points to the right. Okay, at x is less than 4, once again open circle at 4. Less is left, and it also points to the left. And if you look right here, they overlap or intersect in between them. So we want everything in between. So I'm going to shade this part in real dark. Now for our OR. OR is the union of two inequalities, so it's just two different inequalities combined. It's just to be two different ones separated with the word OR and graphed on the same number line. So an example for an OR would be if I have x is less than -1 or x is greater than 3. And the good thing about ORs is there's only one way to write them. This is it. So right here, word OR tells you exactly what type of compound you're dealing with. It also says two different ones, so it gives me 1, 2. And all we have to do now is just graph it. Whenever it says inequalities combined, we mean combined on the same number line. So I'm going to start with -1, 0, 1, 2, 3. So at x is less than -1, then open circle because it's not equal to it, and it points to the left. Less is left, so I shade to the left. Or, so x is greater than 3, so open circle at 3. Points to the right, so I shade everywhere to the right of 3. So if you'll compare the two graphs and wants everything in between, and OR is just two inequalities graphed on the same number line. So big part and is everything in between them, or is two different ones. So let's look at some examples. Example 1, it asks us to graph the solutions x is less than 3 and x is greater than or equal to -2. So the very first thing we do is figure out what type of compound it is, and it tells us it's an AND. We make our number line. We want our smallest number to the left. So between 3 and -2, -2 smaller. And we go -1, 0, 1, 2, 3. So we're going to start with 3. So x is less than 3. Less than means open circle. Less than means left and also points to the left. So I'm just going to shade part of the way just so I know which direction 3 is going. Then we're going to look at x is greater than or equal to -2. So greater than or equal to means I'm going to use a closed circle. And greater than's to the right and it points to the right. So if you look, just shading partial lines, I can already see that it wants everything in between 3 and -2. So let's look at example 2. We're told to solve -5 is less than x minus 4 is less than 2. Now whenever we solve this out, there's actually two methods we can use. So I'm going to show both methods. So our first method, it's going to be a lot like our example. I'm going to drop down our -5 is less than x minus 4 is less than 2. So we look, very first thing we need to see is that our variable is in between our inequality symbols. So if our variable is in between and wants everything in between, so I'm going to go ahead and say it's an AND inequality. And then we're going to have to break it apart into two. So I'm going to take the whole first part and the whole middle. So -5 is less than x minus 4. And now we're going to take the whole middle again in our second inequality symbol. X minus 4 is less than 2. Now if you remember, we said we need to flip the first one here, okay? So we're going to flip the whole thing and even the inequality symbol. So take what's on the take what's on the right and write it on the left, x minus 4. Flip our inequality symbol so it stays eating x minus 4 and stays pointing to the -5. Now we're just going to solve it like an equation. So I'm going to solve for x. So I'm going to take my minus 4, transpose and make my plus 4. And so I get x is greater than negative 5 plus 4 is negative 1. So remember, I solved for one inequality, but compound inequalities have two. So I have to come over here to my second one. So I fill in the same way. Take my minus 4 and transpose it and make him plus 4. He disappears, and I get x is less than 2 plus 4 is 6. If I go back up to my directions, it says to solve and graph. So I'm going to make my graph. Remember, the smallest number needs to go farthest left. So negative 1 and 0, 1, 2, 3, 4, 5, 6. Remember, it's an and inequality. So ands want everywhere in between. So make sure as we graph this that we get everything in between. Oh, my marker's not letting me. There we go. So and. So x is greater than negative 1. Open circle because it's not equal to. If x is greater, greater is right, and it points right. Okay. X is less than 6, so open circle at 6. And it's less than is left, and it points to the left. And look at that. It does want everything in between, everything in the middle. So that's the first method on how to solve these. If we look at a second method, we end up with the same answer. We'll just solve it out a little bit differently. So I'm going to bring over my problem again. Negative 5 is less than x minus 4 is less than 2. So we're just going to focus here in the middle, x minus 4. Now if I want to get x by himself, I'm going to have to get rid of my minus 4. So I'm going to have to transpose him to both sides of my inequality. So negative 5 plus 4, and over here, 2 plus 4. So he disappears out of the middle. And I'm left with negative 5 plus 4 is negative 1 is less than. Got my x is the only person left there in the middle is less than 2 plus 4 is 6. So what you do to one side of your inequality, you have to do to the other inequality. So it's the same thing. We transpose our 4 down here twice. And same way here, we transpose our 4 twice. So there's two methods to solve this one. And then whenever you graph it, same thing, x is in the middle, so you want everything in the middle of negative 1 and 6. So you end up with the same answer. So let's look at example 3. We have negative 3h plus 4 is less than 19, or 7h minus 3 is greater than 18. So it's an or compound, so we just solve it, each inequality separately. So let's go look at the first one here. Negative 3h plus 4 is less than 19. We're solving for h. The first thing we need to do is transpose our plus 4, make him a minus 4. Disappears from the left. I'm left with negative 3h is less than 19 minus 4 is 15. Last step now to solve for h is to divide both sides by negative 3. Negative 3's cancel, and h is. Now, think back to our rules about inequalities. If I divide both sides by a negative, my inequality symbol is going to flip. So instead of saying less than, it's now going to say greater than. 15 divided by negative 3 is negative 5. So I got my first compound. Or, now I solve out my second. Same thing. Transpose my minus 3, make him a plus 3. Disappears from the left and leaves me with 7h is greater than 18 plus 3 is 21. Now, to get h by himself, 7 and h are side by side, means they're being multiplied, so I need to divide both sides by 7. 7's cancel, and h is greater than 3. So I have my two inequalities. They're different, so I'm just going to graph them on the same number line now. We want the one farthest, or the lowest number farthest left, so it's negative 5. It's going to be negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. So it says h is greater than negative 5. So open circle, and greater than wants to the right, and it points to the right. At h is greater than 3. So once again, open circle at 3. Do it once everywhere greater than 3, so right again. So basically, they overlap a little bit greater than 3. So we want the whole right side of our number line shaded in. And that finishes up with our examples for compound inequalities. Thanks.